Now, question 21. This is where we stopped in part 16. We are continuing from there. A lead bullet of mass 0.05 kg is fired with a velocity of 200 meters per second into a block of mass 0.95 kg. Given that the lead block can move freely, the final kinetic energy after impact is dash. So we are going to solve this. Remember that what you are watching is part 17 and we are starting from where we stopped in part 16. Okay, so we have our mass 1 at 0.05 kg, right? You can see mass 1 is 0. Velocity 200 meters per second, velocity 1 200 meters per second, mass 2 is 0.95 kg from the question. Given that the lead block, okay, kinetic energy, we are now looking for the kinetic energy, okay? You can see the solving. You can see the solving. So just substitute these values. I can't explain because I'm not on the board. You are just seeing the screen. Just substitute these values on your own paper and solve. I've often told you, beyond my solving, beyond the classes I give you here on YouTube, you must take the things I teach into your paper, your pen, with you and your calculator and solve. Keep solving. The more you solve, the more prepared you are. Question 22. Remember, we continued this part 17. We continued from where we stopped in part 16. A ball of mass 0.1 kg is thrown vertically upward with a speed of 10 meters per second from the top of a tower 10 meters high. Neglecting air resistance, its total energy just before hitting the ground is dash. Remember that gravitational force is 10 meters per second square. Let's take the question again. A ball of mass 0.1 kg is thrown vertically upward with a speed of 10 meters per second from the top of a tower 10 meters high. Neglecting air resistance, its total energy just before hitting the ground is dash. I'm showing you the solving so that you can substitute on your own. If there is anything you don't understand, you are free to ask me. Remember, just solve with your pen. Just don't watch this. Don't watch this as if you are watching a Nollywood movie or a football match. Get involved. Get your paper and pen and follow me. Now look at this question. A car of mass 800 kg attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is dash. Power is mass times velocity over time. We have our mass as 800 kg and we have our velocity, speed, as that is velocity square now. Its speed 25, that is 25 meters per second, right? Then we have our time. They gave us time as, you know, time in physics and calculation is often measured in seconds as 20 seconds. Assuming it was a minute, we have to convert it back to second by timing it by 60. So we have 20. So when you substitute, you get 2.5.10 power 4. And that is B is the answer. Now pay attention to this question 25. It's a theory question. And I've often told you, if you have followed our classes, that you have more theory questions than calculation-based questions. When the brakes of a car are applied, the frictional force, JAMB like asking this question, even WAEC. When the brakes of a car are applied, the frictional force on the tires is dash. When you match brake as driver in a car, The frictional force on the tires is dash A disadvantage because it is in the direction of the motion of the car. B, a disadvantage because it is in the opposite direction of the motion of the car. C, an advantage because it is in the direction of the motion of the car. D, an advantage because it is in the opposite direction of the motion of the car. The answer is D. Let's look at the question again so that you don't forget. When the brakes in a car are applied, the frictional force on the tires, the answer is an advantage because it is in the opposite direction of the motion of the car. That is why it's able to start stopping the car or to reduce the speed. Let's explain. The frictional force opposes the motion. Friction braking is the most commonly used braking method in modern vehicles. It involves the conversion of kinetic energy to thermal energy by applying friction to the moving parts of a system. The friction force resists motion and in turn generates heat, eventually bringing the velocity to zero. Are you following? Don't forget that we have done several other videos on physics. We have done, what you're watching is part 17. We have done part 1, part 2, part 5, part 10, part 11, 12, 15, part 17. After part 17, we now did 18, 19, 20, 30, and all the rest. We've done several videos on physics. If you need me to give you all the videos we've done so that if you're a serious student, you can begin from part 1, watch part 1, watch part 2, watch part 3. If you want all of them, just tell me in the comment section. Just say, sir, please give me access to all the videos you've done on physics. Then I could give them to you. I could also give you the videos we've done on chemistry, physics, biology, economics, use of English, the JAMB novel, and all the rest. All these things are available to only the members of our channel, registered members of this YouTube channel. If you have not registered, just click on join and join our channel. If you don't know how to do that, ask me how to be a member in the comment section. Question 25. We move on. If the stress on a wire is 10 raised to power 7, and the wire is stretched from its original length of 10 meters to 10.00 meters to 10.05 meters. Okay? The Young modulus of the wire is dash. The first thing you have to ask yourself is, what is Young modulus? I will explain. Okay? Stress over strain. So we have the 0.5. That is the difference. The difference in their length. The difference in their length is 10.05 minus 10.00, which will give you 0.05. That is the stress. Then the length of the wire itself. The original length of the wire is what? The original length of the wire is 10 meters before the stress. Okay? So when you just type, you will get, you can just look at, I often want you to pay attention. Pay attention. Don't just watch this as if you are watching it for me or you are watching a Nollywood film. Get involved. This is your future we're talking about. And I am seriously giving you this materials free of charge because I believe that this year is your year and I want you to claim it. Nothing will stop you from gaining admission this year. It is your portion to enter school this year. Claim it in the comment section and believe it. Don't just claim it. I want you to believe it. That this year you will score 300 and above in your JAMB. This year, you will enter university. This year, even when others score 120 or 130, you will score 300 and above. If you believe it, type I claim it in the comment section. Okay, let me now explain Young modulus. Young modulus is that is E. Young modulus is always stress over strain. It's a property of the material that tells us how easy the material can stretch and deform, and is defined as the ratio of tensile stress to tensile strain. So that is why it is stress over strain. Okay, we move on. 26. A solid weight A solid weighs 10N in air, 6N when forcefully immersed in water, and 7N when fully immersed in liquid X. Calculate the relative density of the liquid X. So when it is in the solid is in air, it is 10N. When it is forcefully immersed in water, it is 6N. When it is now immersed in X, a liquid called X, is 7N. What is the relative density of that liquid? Relative density is always weight in air minus weight in liquid X over weight in air minus weight in water. That is, you already know this thing. 10 minus 7 over 10 minus 6 equals to 3 over 4, which is C as the answer. Okay. Remember, if I were you, as you are seeing this, like you have seen Young Modulo's question, you just go over to your textbook and read it up. Don't watch these videos I give you as if you are watching a football match or love movie or Z World. Once you see me talk about it, go back. Even you may not understand it fully from the way it is shown here. Go back to your textbook, consult it, and do some research. Tax yourself. Make an effort. Look at question 27. When the temperature of a liquid increases, its surface tension dash. When the temperature of a liquid increases, its surface tension dash. A decreases, B increases, C remains constant, D increases then decreases. The answer is A. When the temperature of a liquid increases, the surface tension decreases. Let me explain surface tension. An increase in temperature lowers the net force of attraction among molecules and hence decreases surface tension. Soap decreases the power of surface tension. The gas at a volume of V in a container at volume P is compressed to 1/5 its volume. What will be its pressure if the magnitude of its original temperature is constant? This P1 V1 equals to P2 V2. P2 will now be P1 V1. So you already know that the second P is 1/5 because they say it's 1/5 of the original PO, giving us 5 PO. Let's look at that question again. A gas at a volume, that is the V1 is V0, in a container of pressure PO is compressed to 1/5 its volume. 1/5. What will be its pressure if the magnitude of its original temperature remains constant? So it's P1 V1 equals to P2 V2. That is the same formula you use. Okay, look at this question 29. I hope you are still following. A piece of substance or specific heat capacity 450 falls through a vertical distance of 20 meters from rest. Calculate the rise in temperature of the substance in heating the ground when all its energies are converted into heat. When all its energies are converted into heat. A piece of substance or specific heat capacity 450 falls through a vertical distance of 20 meters from rest. Calculate the rise in temperature of the substance on hitting the ground when all its energies are converted into heat. Of course, you know that your G is always 10 meters per second square. Then option A, 2/9 centigrades. Option B, 4/9 centigrades, 9/9 centigrade, and 9/4 centigrade. We will soon solve, but according to the law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form to another. Always have this at your fingertip. So MC multiplied by change in temperature equals to mgh, right? So simply substitute 10 times 20 over 450, right? I'm sure, looking at the question once more, you know how we got 10. 10 is from gram, right? Times 20. 10 times 20 over 450 that we already have, giving us 4 over 9, making C, option C. Option C. Sorry, making option B. Option B, 4 over 9 degrees centigrade as the correct answer. This question, 30 is complex. That's why I need you to give it your attention. Don't rush. A liquid boils when its saturated vapor pressure is equal to the external pressure. That is I. They will give you some statements. Remember that we have done several videos. If you need me to give you access to all the videos we've done on use of English, JAMB novel, chemistry, physics, biology, government, literature, just tell me in the comment section for the members of our channel. If you are not yet a member, you can ask me how to be a member in the comment section. Okay? JAMB is closed and is not a child's play. Statement 1. A liquid boils when its saturated vapor pressure is equal to the external pressure. Statement 2. Statement 2. Dissolved substances in pure water lead to an increase in the boiling point. Statement 3. When the external pressure is increased, the boiling point increases. Statement 4. Dissolved substances in pure water decreases the boiling point. Which of the above combinations are peculiarities of the boiling point of a liquid? The answer is A. Peculiarities. So I will just mention them. The one that is not correct is dissolved substances in water decreases the boiling point. The one that is correct are I. A liquid boils when its saturated water vapor pressure is equal to the external pressure. II. Dissolved substances in pure water leads to an increase in the boiling point. Then III. When the external pressure is increased, the boiling point increases. All of them are correct. The boiling point of a liquid depends on temperature, atmospheric pressure, and the vapor pressure of the liquid. Boiling begins when the atmospheric pressure is equal to the vapor pressure of the liquid. Look at this question. The temperature gradient across a copper rod of thickness 0.02 meter maintained. I hope I'm not too fast. If I'm too fast, let me know. If you also want to get free JAMB syllables and free JAMB past questions, just subscribe to our YouTube channel and I'll give it to you and become a member. When you're a member, you will get free JAMB syllables and free JAMB past questions on all your 4 subjects. The temperature gradient across a copper rod of thickness 0.02 meters maintained at 2 temperature junction of 2 degrees and 80 degrees centigrade respectively is dash. In our next video, in video 17 that we will do, I will now, or video 18, I will now tell you the answer to this particular. We will continue from where we stopped in part 18. Part 18 will continue from where we stopped. There's a very important video I'm leaving for you on the screen. Ensure you click on it for you to get all those materials or all the videos I've done on those subjects and JAMB syllables and past questions. Do 4 things. Number 1 is compulsory. Number 1 is for you to become a member of our channel. How do you do that? By joining. Click on join now. You cannot escape it. It's compulsory. Click on join and join. If you don't know how to do that, ask me for the link. I will share it with you in the comment section. The next thing for you to do is to like this video. Click on like. Number 3 is to share this video. Click on share. Share this video on WhatsApp. Share it here on YouTube. Share it on Facebook. Share it on Telegram channels, on Facebook status, on all WhatsApp groups you belong to. Then finally, subscribe to our YouTube channel. Subscribe to our YouTube channel. Once you subscribe, come under this video and type I have subscribed. Once you subscribe, do what? Come under this video and type I've subscribed. Once I see you type I've subscribed, I will chat you up with those materials. This video on the screen is for you. I'm giving it to you free of charge. Click on it and watch Now,